Yeah, so in this video, I'm going to discuss about the RNNs, that is recurrent neural networks, and I'm going to focus on one of the branches of RNN, which is called as LSTM. Full form of LSTM is long short-term memory, and it is an extension to RNN because it gives you an extra advantage for doing a prediction based on your past results. So what basically is RNN? As you can rightly see onto this slide, RNN is a special kind of neural network. A neural network is a small network having multiple layers, and each your input is given to the your first layer of the neural network, and it is being processed by successive layers to get a proper output. So what recurrent neural network does is it is a special kind of neural network having a feedback. So xt is your input in this diagram, which is given to your layer of a neural network, and for a normal neural network it outputs a hypothesis ht, but for a recurrent neural network it outputs an hypothesis ht as well as gives a feedback to the next layer. Since this diagram is having just one layer, it is giving feedback to its own self. But if there are multiple successive layers in a recurrent neural network, then the feedback goes to the next layer. So that is how recurrent neural networks are useful, as it gives output hypothesis ht as well as feedback. So that was about the explanation for a recurrent neural network, and it basically has loops. Here you can see a self feedback kind of mechanism, but most probably in most of the cases RNNs are used for giving feedback to the next step. So your second layer's output would depend upon second layer's input as well as feedback from a previous layer. So that is how recurrent neural network is useful. This is a actual implementation of recurrent neural network. uh, in the first diagram here we saw a feedback which is received by its own state, but here there are layers, multiple successive layers of neural network. So this x0 input is given to the first one, it outputs hypothesis h0 as well as it gives the same to the second layer, it provides a feedback to the second layer. Now for the second layer, x1 is the input, but now your h1 hypothesis, which is output, is just not dependent on x1 like it was in the first case. It is dependent on x1 as well as this feedback which is coming from x0 state. So that is how you get h1 state. So this process goes on for successive layers. So output of this layer would be given over here. So x2 along with this feedback would produce h2, and it goes on till the whatever a number of layers are there, and finally ht would be a total output or the correct output or whatever your desired goal output you would want to predict using a neural network. So that is how your neural network, our recurrent neural network will work. And LSTM is a special kind of neural network which has a long term dependency advantage, so that it can remember things for long term without using any memory. So uh, what it I'll give you an example as in how it is different from RNN. So your RNN would here there is an example which says the clouds are in the sky. So suppose if the sentence is given the clouds are in the and dash, so the word sky is predictable because clouds are uh, the only word that fits that sentence would be sky. But so there is no much of the feedback would be clouds which is given here, clouds would be in sky. So that is how RNN would work. But an example of uh, LSTM would be I grew up in France, I speak fluent French. So the first sentence is I grew up in France. Now the module has already learned that you have grown up in France. So its second state would depend on the first sentence. So your first sentence says, I grew up in France. So from the first sentence, it has picked up the word France, and your second sentence has I speak fluent dash. So for France, the language would be French. So this is something which LSTM is able to do, but RNN isn't able to handle such kind of things because RNN does not find a relationship. It tries to uh, see your words and whatever uh, possible fitting word for the sentence you want to predict is being matched. Whereas in case of LSTM, it remembers your past state and your present state mappings are done based on that. So that is how it works. So in this one, this which was a diagram of RNN, your H3 was just based on X0 and X1 as they were. Suppose X0 and X1 is outputting the clouds, so H3 would give sky, whereas in this case your successive output is remembered and the gap over here is the gap between two sentences. In the second sentence also, previous memory is being used or the past learning is being used, and in past there has been a word France used, which is the name of a country. So France people will speak French. So that is how it could predict French. So that is a major advantage of using LSTM, as it gives you a long short term memory. So this is about some history of LSTM. It is long short-term memory networks and it is capable of learning long-term dependencies. It was first introduced by Hochreiter and Schmidhuber, and the main behavior of LSTM was why it came into existence, because remembering information is practically its default behavior. So rather than using RNN, people nowadays prefer to use LSTM because you get a kind of a remembering information ability. So the major reason why RNN has become popular is also because of LSTM. So that is why people are trying to use RNN for various projects in now today's world. For example, predicting an output based on multiple factors, predicting a weather based on soil, temperature, your production, whatever. So sorry, predicting a production based on soil, weather, whatever. So there are multiple factors which can be remembered by LSTM and it can help you improve your accuracy. So this is how a LSTM module looks like. The normal RNN module has just a TANH activation function, which is being used with the second layer's input as well as previous feedback. Both are passed through the TANH activation function to produce the next hypothesis. But in the case of LSTM, there are four layers. There are three sigmoidal activation functions and one TANH activation function. So this is the internal working of LSTM. The upper columnar structure shows a direct feedback wherein just the sigmoidal values are either point multiplicative operations are done or addition operations are done and given to the next layer. And there are three sigmoidal activation functions which output either 0 or 1, whether to keep that output, use that output, or you just discard it. And TANH activation function is also being grouped with your input, which also is given as a feedback to the next layer. So that is how it is different from RNN. RNN just had a TANH function, where activation function, whereas LSTM has three sigmoidal activation functions and one TANH activation function. So there are four interacting layers in the internal structure of LSTM. So these are few of the uh, ways to represent that internal structure. The core idea behind LSTM was that there is a conveyor built on the top, which I told you, CT minus 1 is the previous feedback and your next would be CT. So it works in that way. Just the multiplicative factor and the addition factors are, so with the multiplication and addition factors you get CT. Now, this is how the operation works. A sigmoidal layer outputs either 0 or 1. 0 means let nothing through, or 1 means let everything through. Or it sometimes, depending on what application you are running, 0 means take the, I mean, just discard the output and the previous state output, and 1 means just use that output for the next state. So uh, I live in France. I speak French. So these two would keep the word would give an output of 1 for France, which would be used to predict French, as the example was given before. So these are the xt is the input, ht minus 1 is previous hypothesis. So both are passed through a sigmoidal activation function, which is then uh, passed through a multiplicative point operation. Then there is, these are also passed through sigmoidal as well as tanh, and their outputs are clubbed using multiplicative point operator, and then given to an addition operator which combines the output from the previous sigmoidal layer, which was multiplicative, which was performed a multiplicative operation with the CT minus 1, and this operation are grouped with the plus operator to give CT. So these are the formulas which tell you that tan H activation function and sigmoidal are grouped together, and Ft was the previous one, so Ft into Ct minus 1 here, which is the multiplicative one, and It, which comes from here, from sigmoidal of second sigmoidal function, and Ct comes from the tan H one. So these two and these two are added to give you Ct. So that was about LSTM and RNN, in-depth explanation about both the things. So LSTM is something which is really fascinating, and that is why RNN is been so much into existence because of LSTM, because LSTM provides an extra memory kind of thing which improves your module's accuracy. So yeah, thank you so much.